Hi guys, I'm Eli Tutor. Alright, so today I'm going to be looking at physics 001 for the 2026 UTM for the 2026 UTM. So we are going to be looking at um, application of Boyle's Boyle's law. Application of Boyle's law. So that's what we are going to be looking at in that physics. So it's a revision class. Alright, so moving on to the application of Boyle's law. And we are going to be considering a capillary tube, its application to a capillary tube, and also to a swimming pool. So these are the two things we are going to be applying in Boyle's law. Quickly, there will not be much time for proving, so rather I'll just give us a shortcut that we can use to solve problems regarding this application. So whenever you see it, you can be able to go about it. Now, starting on with this, let me begin with capillary tube. Now, recall by principle. If you recall by principle, you remember that Boyle's law states mathematically that P1 is equal to what? V2 P2. Do we agree with this? Now, if I have a capillary tube, suppose I have a capillary tube, I'm going to be touching this one, starting with this section. So under the capillary tube, it's going to be divided into three sections. We are going to be having the let me say the vertical tube, and we are going to be having the inverted tube. We are going to be having the horizontal tube. So it's just divided into three. This capillary tube is subdivided into three type of tube. So looking at how does the vertical tube looks like. So the vertical tubes goes this way. Suppose this is the vertical tube. Inside here we have the atmospheric pressure P. Okay. So at the middle here we have what we call the mercury thread. Okay. Here we have the mercury thread. Here. Okay. Now, inside here we have our gas. Okay. Inside the whole of this place we have our gas. But regardless, whenever you have your vertical tube, this is a vertical tube. In this your vertical tube, you say let this place be X. Okay, the side of the mercury thread, and down here where we have the gas, we said let it to be Y1 for the first tube. That's the vertical. And inside here, don't forget that it is what the atmospheric pressure P. Now, don't forget again that this is the vertical tube. Now moving on onto the inverted. The inverted tube looks this way. So you see the inverted tube, this region still remain our X. They used to have the same value for X, even if we are having 2 to 3 kind of tube. And this place still remain our mercury thread MC. And this place still remain our X. Nothing changed about X. We don't have X1, we don't have X2. The only thing that changes is the Y down part here when we have the gas. Then we have this place to be our Y1 for the inverted capillary tube. Inlet here, we have atmospheric pressure capital letter P again. Alright, so now for the for the horizontal. So for the horizontal side, still the same, nothing changed about X. This is still our X. Don't forget this is the mercury thread, and this side we have our gas, and don't forget this place being, this is our x, this place being our y3. Sorry, this is going to be y2, this is y1, this is y2, and this one is going to be y3. And inside here we have our atmospheric pressure, P. Is that clear now? So moving on, there's a formula that connotes this equation that represents this. So the equation that represents this first two, which is vertical two, is P with y1 into P plus x. All right. So the first two is what? Y1 into P plus x. So what is the equation that connotes this? The equation that connotes this second one, the inverted, is, don't forget, we have what? Y2. Where is it? This is Y2 into, since this one is addition, this one is subtraction, inverted. You understand? So now what will be this? So the equation for this is going to be just y3p. Is that clear? So now, which means that the idea behind this is that the vertical is equals to the inverted and equals to the horizontal value. That is, it implies that y1 into p plus x is equals to y2 into p minus x and equals to y3 and p. Now, suppose I was having a question like, okay, suppose I was having a question. Okay, let me clean this guy. I'm cleaning this guy. It's the duster. Sorry, I'm coming. Alright, let me clean this guy. I believe we are jotting. Can we see it from there? Okay, thank you. Alright. Suppose I was having a question that says that, anyway, I'm going to give you a theoretical question. For instance, work example 1.0. Work example 1.0. Where's that ink? Where did I put it? Seems like we are going to manage this. If I draw the ink, maybe that could be. Where did I put that ink? Anyway, let's proceed. So, work the example 1.0. Suppose I have something like this. Maybe I have, let's say I have the inverted. Then this place, let this place be 5. Let's make this place 25. And I have something like this. Let me make this place 25 as well. Okay. So, and I am asked to find the atmospheric pressure, for instance. But don't forget, maybe this place I have something like, for this side I have 10 centimeter, and here I am having something like 15 centimeter. So find the atmospheric pressure. suppose I ask a question like this, and I was told to find the atmospheric pressure. It comes out every year in Jamb. You understand? You can try it. So, okay. Remember the equation for this guy. So whenever it is vertical, that is what y1 into p plus x. You understand? Then equals to whenever it's inverted, that's what y2 into what p minus x. So my y1 for this is this as 10 into this is what we are looking for, the p plus 25 equals to 15 into what 25, no, it's p we are looking for, minus what is our x? Our x is 25. All right, so here we have 10p plus 250, right, equals to 15p, okay, minus 15 times 250, that's 250 times 5, 15 times 25, that's 250 times 5 left. No, this can it be no? That's wrong. Okay, let's solve it. This one is 25 and 11, 12. That's 325. That's 375. 375, right? So that's it. So we now have CLT, we call it like terms. And that's what? 4, that should be 425. Am I correct? That's 425. 500, 4, yeah. Okay, so equals to 5p. Then p is equals to 425 divided by 5. So that should be that's 85. So 85 centimeter mercury. Giving option that at the end of the day you will be having something like this as your option. So imagine, supposing they are giving you like, they can give you like 3, they might not limit it to this 2, they should give you like 3. So you find your way around it. Just solve it the way, whenever you are giving something like 3 tube, you solve it the same way you used to solve sine rule. Like when you have sine rule, you know how to go about it. Because themselves, then when the unknown is found, they can now make it equals the other one you are looking for. So I'll move on to swimming pool. All right. Are we together? Okay. All right. We shall be cleaning this now. So I want to move on to the next aspect. Now, for the next one, I want to talk about the application of Boyle's law to swimming pool. Swimming pool. All right. So the application of Boyle's law to swimming pool aspect now. So when you talk about swimming pool, let's assume we have something like this, a pool of water. This is the down. This is the down part of the pool of water. You know, when you have a swimming pool like this, you have a swimming pool like this. This is your swimming pool. This place is the surface of the swimming pool. This is a pool of water, right? But in it, we call it total swimming pool. You understand? So now, in this place, enters the atmospheric pressure, always enters the surface. Now, this place like this region like this place like this is the height of the swimming pool. Exactly. And don't forget, if I take a stone, no matter how big or how small the stone is, if I throw it inside a pool of water, you notice that something happens. And what happens? Down here, we have bubble. A bubble will show up. You understand? But regardless of whether the bubble show up or not. So if the bubble will come up, like when you throw something inside water, you see that you observe that there will be a bubble that will rise up. So the bubble does come from the bottom, not the surface. You understand? Because if a bubble comes from the surface, it will go down. So definitely a bubbles come from the bottom. So that's why the bubble comes from here to the top. So that makes us have V1 here. So we have our V1 and P1 here. So P1. So the bubble comes from the down to the surface. So we have another bubble at the top here that comes here. Bubble of gases, you understand? I mean bubble rather, sorry. So this one becomes what? V2, and this one is P2. Another thing I want you to understand that by Boyle's law, we want to use Boyle's law to prove the equation for this. By Boyle's law, we have V1 equals to V2. So if you are relating this Boyle's law to this swimming pool now, it becomes V1. V1 is for the down. So what will now be our P1? The P1 expression is for the down part. Bubble coming from the down becomes P plus H. It becomes the atmospheric pressure plus the height. That is the expression for the P1 at the bottom of the swimming pool. Now, but the V1, V2 is the same, but you have to note that P2 is the same as the atmospheric pressure. Atmospheric pressure P. So same as the atmospheric pressure P, which now in turn implies that B1 into P plus H is equal to V2 and P. So this is now the final equation for Boyle's law equation for what? For swimming pool. For bubbles in swimming pool. Alright, so that is as a swimming pool now. So I'll be solving a question. Okay. Suppose I'll be doing this guy. I'll give us two questions that you will understand. And I know that by the time I write the question outside, you'll be able to solve the problem. So I shall be cleaning this. Alright, I can see you. Thank you. Please leave a comment. Alright, I shall be cleaning this. Alright. Suppose we have something like this. This example 2.0. Suppose I have something like this, and I have this, then this is my height. Let's say my height to be 7 meter, and my V1 inside this pool is 2 centimeter cube, right? And my P1 here is, let's say that my atmospheric pressure here is 12 centimeter mercury. So, and my P1 is let's say my P1 to be 5 centimeter mercury, and my V2, I said you should find V2. This is a pool of water. And I'm having a bubble at the top side, bubble at the bottom, and bubble at the surface. So what's the equation I said we should use? That's equation for bubbles in a swimming pool becomes V1 into what? P plus H, that's height of the swimming pool, is equals to V2 then P. You understand now? So you have a question like this. So that will be, what's my V1? My V1 is given as 2 into my P is 12 atmospheric pressure plus height, that's 7, is equals to, we are looking for V2, that's V2 multiplied by, P2 is still the same thing as atmospheric pressure, that's 12, right? So 2 here 1, 2 here 6, then we're having what? This one becomes 19, right? Is equals to what? 6 V2, and my V2 is equals to 9 by 6. That should be 2 point or 3 point something. 9 divided by 6 as my V2 becomes 3.17 centimeter cube. So this is my final answer. That's my final answer. So I'm going to drop 2 questions for you to solve on this application of Boyle's law, so that, and I believe that my explanation is very fair. Okay, thank you. Long commented by top fans. Who will they comment instead? Let me give us a classwork. So you drop your answer in the comment section. If you're able to get the correct answer, I have a token for you. Don't worry, I'll give you 2,000 naira. You solve it clearly, you prove you solve it correctly without the use of AI. I will know if you use AI. So let's say the first question one for you to try, then drop your answer in the comment section. It's just going for 2,000 naira. Just 2,000 naira. So if you're able to get this correctly, you won a 2,000 naira. Alright. Drop your answer in the comment section and your solution, evidence of your solution. Look for my number around my videos and send it to my DM. Okay, so this place, I don't know the years is in your Jamb pass question. This is 40 centimeter. This place is 25 centimeter. Okay, this place is 20 centimeter. You have dry air here. Mercury thread. Dry air is trapped by a fillet or mercury of length 25 centimeter in a uniform capillary tube above it, the open end uppermost, a the length of the air column is 20 centimeter when the capillary tube is inverted. The length of the increases,